Good evening, students. So if you are joined in the class, comment below. Ranjit, this is English medium class, Ranjit. Good evening, Pooja. So in yesterday's class, up to Coulomb's law we have C, correct? Have you all remember in yesterday's class we have C up to Coulomb's law and the problem related to Coulomb's law, okay? Good evening, Brit, okay? So what is Coulomb's law? The Coulomb's law states that, what is Coulomb's law? If you know, tell me in the comment. So the Coulomb's law states that force is directly proportional to product of two charges and the distance between the charges, correct? So this is the Coulomb's law, and when we remove this proportionality we can get F equal to K Q1 Q2 divided by R squared, okay? So we also know that the value for K is 9 into 10 power 9 n m squared c power minus 2, and also the K is nothing but 1 by 4 pi epsilon naught. This epsilon naught is the relative permittivity, correct? No, this epsilon naught is permittivity of free space. Correct? Have you all remember? We have seen these Coulomb's law, basics of Coulomb's law in our yesterday's class, correct? Have you all remember? So if it is okay means tell me in the comment, or if you have any doubt ask me in the comment, okay? Yes, okay, Brito, okay. So in yesterday's class we have seen one problem based on Coulomb's law, correct? So in today's class we will start with the problem, okay? So 2 point charges plus 3 mu c and plus 8 mu c, which is repel each other because both are in the positive charge with a force of 40 Newton. If a charge of minus 5 mu c is added to each of them, then the force between them will become, okay? So what are the values first? What are the values they have given in the question? So they have given two charges, which is 3 plus 3 mu c and plus 8 mu c, okay? So and also they have given 5 mu c of charge is added, 5 mu c of charges is added with both of them, okay? So then what will be the force? Now what will be that new force? That is the question, okay? So the options are also given the question in this question. So we know that force value formula is K into Q1 Q2 divided by R squared, okay? So see here, this is one particle which is having 3 mu c, okay, and another one particle which is having 8 mu c, okay? So after that what will happen? The force is 40 Newton, okay? The force is 40 Newton here, and after that 5 mu c charges added with both of them, okay? So minus 5 mu c is added with this charge and also with this charge, okay? So when we add these two charge we can get minus 2 mu c. Likewise here 3 mu c. This one is minus 2 mu c and this one is plus mu c, okay? So here they have asking Good evening, Nikita. Here they have asking what is the force between them will become now. Okay, so the new force will be, we will substitute the given values here. So we know that force is 40, K value is K, Q1 is 3 into 10 power minus 6, because it is, we know that the charge, the unit for the charge is coulomb, correct, but here it is mu C, so for mu I substitute the 10 power minus 6, okay, into, for Q2 is 8 into 10 power minus 6 divided by r squared value. R squared value we don't know, so just they didn't give in the question, so just put r squared. Okay, so now we are going to find out the F nu. So F nu is K into minus 2 into 10 power minus 6 into plus 3 into 10 power minus 6, okay, divided by r square. Okay, so here I am going to find out this F nu value, so I am going to divide these two equations. Consider this as first one and this one as second one. So F nu divided by 40, which is equal to K into minus 2 into 3 into 10 power minus 12 divided by r squared, the whole divided by K into 3 into 8 into 10 power minus 12 divided by r squared. So this r squared and r squared will get cancelled, K and K will get cancelled. Okay, likewise this 10 power minus 12 and 10 power minus 12 will get cancelled. Okay, have you all understood, or do you have any doubt? So we can get F nu will be equal to 40 into minus 6 divided by 3 into 8. Okay, so when we solve this, here 40 will come this side. So when we solve this, we can get F nu as minus 10 Newton, because the minus is present here, no? So the F nu value will be the minus 10 Newton. Okay, have you all understood? Or do you have any doubt? If you have any doubt in this problem, means tell me in the comment. Do you have any doubt? If you have any doubt, tell me. Otherwise, we will move on to the next one. If you have any doubt, tell me in the comment. Otherwise, we will move on to the next one, ma. Okay, we will move on to the next topic. Okay, we will move on to the next one. So the superposition principle. Next one is superposition principle. So far we have seen Coulomb's law. Okay, so the Coulomb's law is applicable for two charges which is in static position, correct? So in the Coulomb's law we have two charges which is Q1 and Q2, both are in static, correct? So in the Coulomb's law we have the charges Q1 and Q2 which is are in stable position, which is our rest. We have solved the force for these two, okay. But in the superposition principle, so for n number of charges, if we consider any one system, if there is n number of charges are present, if the n number of charges are present in the system, means we will use the superposition principle to solve that force in that system, okay. Did you understand? Did you understand clearly? So we have so in Coulomb's law we have see about force between two charges, both are which is in static, okay. So in the superposition principle, it is used to find out the n number of charges present in the system, okay. The force between n number of charges which is present in the system, okay. Did you understand? Consider there is a particle, there is a charge which is present here, and there are multiple charges which is present here, okay. So this all charges are will collide with, consider this all charges will collide with this charge, okay, with this charge alone. So we have to find out the force between these two charges, okay. Did you understand? So we have to find out the force between acting between these charges and this single charge, okay. Good evening Kural, good evening, okay Pooja. Okay, so consider there is a system, okay. So consider there is a system and the number of charges will be present in that system, okay. So consider one charge is present here and remaining charges are present here. So this all charges are with giving the force, okay, force to this. So we are going to find out the force between these two charges, okay. The force between this, the force between these two charges, okay. Consider this as the particle 1 and this one is 2, 3, 4, 5, 6, okay. So here we are going to find out the forces between these number 1 charge and between these charges, okay. So first when we find out the force between this charge and this charge will be force 1 to K Q1 Q2 divided by R21 squared R21 cap, okay. We have already seen in yesterday's class, no. So this is the unit vector. So next one F13 vector, which is equal to K Q1 Q2 divided by R31 squared R31 cap. Likewise it will goes, correct. So we have just consider n number of charges here, but it will goes for, here we have considered 6 charges, but it is goes for n number of charges, correct. So the total force will be equal to F12 vector plus F13 vector plus F14 vector plus etc. F1n vector, because n number of charges will present here, correct. So K will be constant in all the terms. Then we will write Q1 Q2 divided by R21 squared R21 cap plus Q1 Q3 divided by R31 squared R31 cap plus etc. Q1 Qn divided by Rn1 squared Rn1 cap. Did you understand? So this is the superposition principle. So we have to find out if the number of charges, we know that the number of charges will be present in the system. So if we want to find out the force in the whole system, means we should use this formula, okay, because there will be the number of charges will be present, okay. So here the n number of charges will be present here. So the superposition principle is used to solve the force between the the n number of charges which is present in the system. Okay, have you all understood? Shall we move on to the next one, or do you have any doubt? If you have any doubt, tell me in that comment box. Okay, okay, did you understand? Shall we move on to the next one? Or if you have any doubt, tell me in the chat box. Okay, you can communicate with me with the chat box. Okay, okay, Pooja. Okay, then we will move on to the next one. So if you have any doubt, or if you want to ask me anything, means just tell me in that chat box. Okay, then only we can communicate. Okay, so the next one is electric field. So this electric field is proposed by Faraday's concept. Okay, so this electric field is proposed by Faraday's concept. Okay, Pooja. Okay, so consider there is a charge inside the, consider this will be the room. So the charge, a single charge is present inside this room. There is no movement. Okay, this charge is still in the same position. Okay, so there is no movement in this charge, means there is no presence of electric field here. Okay, so consider this same room. We have considered the same room. A charge is present here, and this charge is moving towards this wall. That means there will be the presence of electric field. Okay, so if the electric field is present in any one system, means what will happen? Automatically the charge will get repulsion or attractive force. Okay, so this electric field is defined as force experienced per unit charge. Okay, force experienced per unit charge is called as electric field. Okay, so the force experienced per this unit charge is called as the electric field. Okay, so we know that according to the Coulomb's law, what is the force according to the Coulomb's law? From Coulomb's law, we know that F vector, which is equal to K into q naught divided by r squared r cap. Okay, so instead of q1 q2 I have taken q naught. Consider, so there is a q and q naught is present here. The distance between these two particles is r. So the force according to the Coulomb's law, the force acting between these two charges will be the q naught divided by r squared r cap. Okay, so I am going to substitute this F vector value here. Okay, so here I am going to find out what is the force experienced by this q due to this q naught. So I am going to consider this E vector will be equal to F vector divided by q naught, which is equal to k q naught divided by r squared into r cap divided by q naught. So this q naught and q naught will get cancelled. We can get E vector will be equal to F vector, no, E vector will be equal to kq divided by r squared r cap. Otherwise k, instead of k, what we can substitute? 1 by 4 pi epsilon naught q divided by r squared into r cap. Did you understand? So this will be the electric field formula. Okay, so this is the basic formula. So the force experienced per unit charge is known as electric field. Okay, so when the presence of electric field, there will be the electron will have the attraction or repulsion force. Okay, so if there is no electric field is present here, means what will happen, there is no movement in the electron. Okay, so we know that formula for electric field is F vector divided by Q. Okay, so according to Newton's law, we know the formula F vector, which is equal to K Q Q naught divided by R squared. Here I have considered the particles Q and Q naught, so I have taken the charges as Q and Q naught. Okay, so here I am going to find out what is the electric field which is present here due to this Q naught. So I go to substitute, instead of Q I am going to substitute Q naught. Okay, so there will be, obviously there will be the, if the electric field is present, means obviously there will be the force of attraction or repulsion will be present on the charges or particles. Okay, have you all understood? So if the problem is based on electric field, means you should use this formula 1 by 4 pi epsilon naught Q by R squared into R cap. Okay, so if the R distance value is present here, means you should use this formula to find out the electric field value. Okay, shall we move on to the next one? Or if you have any doubt, tell me in the comment. Which Coulomb's law, Nityashree? Yesterday's topic, huh? Or this one? This Coulomb's law you didn't understand, huh? Which one? Tell me clearly, Nityashree. I will repeat it once again. This Coulomb's law or yesterday's topic or basic Coulomb's law you don't know. Which one you can't understand? This topic. Okay, today's topic. Okay. So in the superposition, first we have start from the superposition principle. Okay, Nityashree. So by using this superposition principle, we know that by using the Coulomb's law, we can find out the force between the two particles alone. Okay, so if the n number of particles or n number of charges are present in single system, means the superposition principle will be used. Okay, so this force will be written using the Coulomb's law. So after that we should add all the forces present here, so we can find out the force which is acting on whole system. Okay, Nityashree. So in this topic, so if the electric field is nothing but, it states that the force experienced per unit charge is known as the electric field. Okay, so if there is no electric field is present in the system, means what will happen, the charge will be the rest, will be in the rest, there will be no movement in the charge. Okay, same wise, if the electric field is applied on the charge, means what will happen, there will be the attractive force or repulsive force which will be acting on the particle. Okay, so here we know the formula. So this will be this electric field formula. So from I am going to consider two particles, which is Q and Q naught. So I am going to find out the force between this Q and Q naught. So this will be the force between the Q and Q naught charges by using the Coulomb's law. Okay, so here we know that formula for electric field. So I am going to substitute this force value in here and divided by Q naught. Okay, so here I am going to find out the electric field force experienced by the Q naught on the Q. So I am going to substitute the Q naught instead of Q. Okay, so just substitute this force value here. From this you can find out the electric field value. Okay, so hereafter if in the questions there will be the distance is present here, means you should use this formula. Okay, have you all understood? Nityashri, did you understand it now? Nityashri, did you understand it now, or still do you have any doubt? Okay, Nityashri, good. So the next topic is so here we are going to see the remaining cases which is based on the electric field. Okay, so the electric field due to the system of point charges. Okay, so we know that the formula for electric field is F vector divided by Q. Okay, and one more thing, the unit for this electric field is Newton per Coulomb. Okay, because the unit for force is Newton and the unit for Q charge is Coulomb. Okay, so the force divided by Q Coulomb. Newton per Coulomb is the unit for electric field. This is the unit for electric field. Okay, so here we are going to find out the electric field due to the system of point charges. Okay, so consider this is the point charge P and these are the charges Q1, Q2, Q3. So here there are the multiple charges. Okay, so there are the multiple charges which create the force with this point charge. Okay, so see here, this Q1 and P will create a force, and Q2 and P and Q3 and P. Okay, so this will be the point charge P which is present here. Okay, so the point charge P is present here. So and also the number of charges Q1, Q2, Q3 are present here. Okay, so this point charge, here we are going to find out the electric field which is due to this multiple charge on this point charge. Okay, did you understand? Here we are going to find out the electric field of that point charge due to these number of multiple charges. Okay, did you understand this concept? So here we are going to use what principle? Superposition principle. Okay, so we have already know that. So if the n number of charges are acting on the system, means we should use the superposition principle. Okay, so we know that electric field formula is 1 by 4 pi epsilon naught Q divided by R square. Okay, so we know that here we have considered the 3 charges. Okay, so the total electric field of the system will be equal to E1 vector plus E2 vector plus E3 vector. Okay, so we know the formula for E1, which is K Q1 divided by R1P squared into R1P cap plus K Q2 divided by R2P squared R2P cap plus K Q3 divided by R3P squared into R3P cap. Okay, did you understand? So instead of electric field, we are going to substitute the formula. Okay, so K into Q1 divided by R1P squared. Okay, so in the previous one we have concluded with this formula, no? So here this Q1 is exerting the force on P, so due to that we have find out the electric field for each charge. Okay, so we have considered the Q1, Q2, Q3 on P. So P is present here. Okay, did you understand? So take this K value in the outside. So K into Q1 divided by R1P squared R1P cap plus Q2 divided by R2P squared R2P cap plus Q3 divided by R3P squared into R3P cap. Okay, so this is the electric field which is present on this system. Okay, so when we consider for this whole term, E total will be equal to 1 by 4 pi epsilon naught summation I equal to 1 to n Qi divided by RIP squared into RIP cap. Did you understood? So in this case we are going to consider number of charges which exerts the force on this point charge P. Okay, so this will be the, so we have taken the summation of I equal to 1 to n. So we can substitute for this I up to 1 to n values. Okay, have you all understood? So this will be the formula for the system electric field due to the system on the single point charge. Okay, did you understand or do you have any doubt? Shall we move on to the next one? Shall we move on to the next one or do you have any doubt? If you have any doubt, tell me in the chat box. Okay, shall we move on to the next one? Shall I move on to the next one? Shall we move on to the next one? Okay, I will move on to the next one. Still, if you have any doubt in this topic, means tell me in the comment. Okay, so the next one, electric field due to continuous charge distribution. Okay, so far we have discrete particles. Okay, so here it is the continuous charge distribution. So the distribution means we will have one discrete means single particles. We know that Q equal to NE. Okay, so for continuous, here in the topic is we are going to see about for continuous charge distribution. When we consider this continuous means we have three cases. The first one is linear and the second one is surface area and the third one is volume. Okay, so discrete in the sense, so far we have seen the discrete particles only. Okay, because particles will be present here Q1 and here the Q2 will be present here, correct? So in this topic we are going to see about the continuous charge distribution. So there are the three types in this continuous charge distribution, which is linear, surface area and volume. Okay, so I am going to write this in the form of, first we will find out the electric field value for the continuous charge distribution. Okay, so in the previous case we have so in this case we have taken the regular shape to find out the electric field. So we know that the value from there is electric field KQ divided by R squared into R cap. Okay, so if we consider the irregular shape, so here the point charge, so here the number of charges present here. So consider this as the del Q1, del Q2, del Q3, del Q4. Okay, so the total electric field here will be E1 plus E2 plus E3 vector. Okay, so we can get k into del q1 divided by r1 p squared into r1 p cap plus k into del q2 divided by r2p squared r2p cap plus etc. The number of charges obviously will be present here, no? So k del qn divided by rnp squared rnp cap. Okay, so when we solve when we take this in the format of summation, we can get E total, which is equal to k into summation I equal to 1 to n del qi divided by rip the whole squared rip cap. So we can also rewrite this as E vector, which is equal to k integral of del q divided by r squared into r cap. Okay, so in the form of continuous charge distribution, to get the electric field we should integrate the given terms. Okay, because when we consider the irregular shape, first we will take the q1 point, so the area will be this one, and here for this area will be this one, and here this one, because this will contain the small area only, no? So we have take del q1 del q2 del q up to del qn. Okay, so the electric field here will be equal to k integral of del q divided by r squared into r cap. Okay, so we have already see there is the three types present here, which is linear, surface and volume. Did you understand up to this one? So if there is a continuous charge distribution, we have considered the irregular shape for that, so the electric field will be this one. Okay, so now we will write this electric field formula for the linear, surface area and the volume. Okay, have you all understood this one, or do you have any doubt? If you have any doubt, tell me in the chat box. Okay, Hajar, listen here. So far we have seen the discrete distribution of charges. Discrete in the sense single particle. Okay, single charge, correct? So here the charge will be present, and here the charge will be present. Okay, so in here in the continuous charge we are going to take the form of continuous charge distribution. Okay, so when we take the continuous charge distribution, these are the three cases. First one is linear and the surface area, and the third one is volume. Okay, so for here I am going to consider the irregular shape. Okay, so irregular shape, I am going to consider the irregular shape. So when we consider the irregular shape, it will occupy, this charge will occupy the small space only. So for q1 I substitute the del q1, for q2 del q2, and for q up to del qn. Okay, so for E vector will be equal to, so when we put summation, the E value will be equal to E vector, which is equal to k integral of del q divided by r squared into r cap. Okay, so when we have take the small space, small charge. Okay, so small in the sense we have to integrate that one. Okay, so for this I am going to, did you understand, Haja? So I am going to find out the formula for these three terms: linear, surface area and volume. Okay. So we will write in the form of differentiation. Okay, so the first one, differentiate linear type, and the second one is surface area, and the third one is volume. Okay, so the first one, consider, it's okay Haja. So consider there is the paper, there will be the multiple charges will be present here, correct? So for the linear, the formula is lambda, which is equal to Q by L. Okay, so for surface area, for linear we will take the charges, okay, charges, positive charges, which will be present here. So if, okay, so for number of charges just select one charge, so that is the linear one. Okay, for surface only we are going to consider the paper, so there will be the number of particle, positive and negative charge will present here. So from this we are going to consider one single particle, so that is sigma. Okay, surface charge density. Okay, so this is the linear, this is the linear density, this is the surface charge density, and the next one I am going to consider the cube. For volume I am going to consider the cube, so there will be the number of positive and negative charges are present here. Okay, so consider the cube for volume. Rho will be volume density, rho will be equal to Q divided by V. So in the linear we have considered the length here, for the surface we have considered the area, so for the cube we have considered the volume, so V. So for this length, so L, here the area for A, here the volume for V. Okay, so when we solve this, we can, when we differentiate this one, we can get lambda equal to dq by dl. So lambda dl will be equal to dq. Okay, so same way sigma will be equal to dq by dA. So sigma dA will be equal to dq. Okay, so like here, rho will be equal to dq by dv. So rho dv will be equal to dq. So if we are going to find out the charge distribution in the linear system, means you can use this formula. So this is the linear charge density, and this is the surface charge density, and this is the volume charge density. Okay, so when we use this formula in the electric field, in the integration formula we have find out, no? So when we substitute in that formula, means we can get E vector will be equal to K into lambda dl divided by r squared into r cap. Okay, so we know that the E vector value will be equal to K integral of del q divided by r squared, correct? Del q divided by r squared into r cap. Okay, so instead of this del q, I am going to substitute the values we have find out for the each case. Okay, so this is the electric field which is present in the linear system. So the electric field in the surface area will be E vector, which is equal to K into integral of sigma dA divided by r squared into r cap. Okay, so here in this situation E vector will be equal to K vector into lambda dl divided by rho dv divided by r squared into r cap. Okay, have you all understood this concept, or do you have any doubt? So if you have any doubt, ask me. Okay, shall we move on to the next one? So these are the three formulas for the continuous charge distribution, which is present in different types of areas. Okay, Haja, okay, Srinivasan, okay. So then we will move on to the next one. So we will see one problem based on electric field. A conducting sphere of radius 10 centimeter has unknown charge. Okay, unknown charge if the electric field at distance 20 centimeter away from the center of the sphere is 1.2 into 10 cube Newton per second and the points radially inwards, the net charge on the sphere is. Okay, so options also they have given. What A value they have given as, A value is, they have given, R value they have given us 10 centimeter. So R value they have given us 10 centimeter. So this R is the radius. Okay, so this R is the radius, don't consider this one. Here we are going to find take the distance value R, which is equal to 20 centimeter. So when we converted into the meter, we can get 0.2 meter. Okay, so if the electric field, so the electric field, which is the 1.2 into 10 cube Newton per second. Okay, so the electric field at distance 20 centimeter from the center of the sphere is 1.2 into 10 cube Newton per second. So which is in opposite direction, because it is in inwards, so it is in opposite direction. So just put minus sign. We know E value, which is equal to Q divided by 4 pi epsilon naught R squared. So Q value will be equal to 4 pi epsilon naught into R squared into E. Okay, so when we substitute, what is the formula for 4 pi epsilon naught? 1 by, we know that 1 by 4 pi epsilon naught is equal to 9 into 10 power 9. Okay, but here the 4 pi epsilon naught is in numerator, correct? So we have to write 1 by 9 into 10 power 9 for R squared, 0.2 into 0.2 for electric field, minus 1.2 into 10 cube. Okay, so when we solve this, we can get the answer minus 5.3 into 10 power minus 9 coulomb. Did you understand? So the answer for this question is minus 5.3 into 10 power minus 9 coulomb. Have you all understood this one? Okay, Pooja, have you all understood this problem? Or do you have any doubt? If you have any doubt, tell me in the comment. In the last step. Okay. Okay, Pooja. See here, Pooja, we know the formula for electric field, correct? So the electric field formula is Q divided by 4 pi epsilon naught R squared. Okay, so here we are going to find out the charge only, because we know that the charge is unknown here. So here we are going to find out the charge value. So 4 pi epsilon naught into R squared into E. So this 4 pi epsilon naught will be go in this direct side. Okay, so we know that 1 by 4 pi epsilon naught formula is value is 9 into 10 power 9. Okay, but here this 1 by 4 pi epsilon naught is in numerator. Okay, so the 9 into 10 power 9 will become 1 by 9 into 10 power 9. Okay, so we know the value for R, so 0.2 into M. Likewise, the electric field value is 1.2 minus 1.2 into 10 power 3. So when we substitute the known values, we can get the minus 5.3 into 10 power minus 9 coulomb. So option C is the correct answer. Have you all understood this one? Or if you have any doubt, tell me in the chat box. Okay, Pooja. So we will wind up the class today. So still, if you have any doubt, ask me in the comment box. I will repeat it once again in tomorrow's class. Okay. So do you have any doubt? Okay, then we will wind up the session today. Okay, ma, thank you.